Kia ora. This video is for people who sat the Wellington College Scholarship Calc fake exam this year. I'm slowly making my way through doing videos for most of those problems. The ones I can't get videoed, I'll put some worked solutions up for. Remember, if you haven't picked up your paper, please come and see me tomorrow or the next day. Okay, this one was a kind of a warm-up question that most of you did really well with. And it's just to get you thinking about all of the level 1 geometric reasoning stuff that comes in so handy in problem solving. So here we've got a circle, it's sitting inside a right angle triangle, and the radius of the circle is 3 and length BC has length 8. And we just have to find the perimeter of the triangle A, B and C. So this question was really well done, but some of you did it in quite inefficient and sometimes really inelegant ways as well. So I'm going to show you how I did it. And feel free to use a different way. So I guess the two things that I noticed in here were that I have got a circle and I've got this point C is formed by the tangents to that circle. So let's just pop on those lines there. Right, and so like as soon as you see those in a different color, hopefully that makes you remember that rule from year 11 or year 10, which is that the distance from a tangent to the circle, if you've got a point here, then those two lengths are going to be the same, right? And then if you see that a second time, and I know you can't, I guess you can take colouring pencils into the exam, maybe you should. Here's my little purple line here. We've got the same thing going on here and here. So I'm going to mark in some extra markers. I called this, what did I call this, point P and this point Q. And we're very helpfully told that the radius of the circle is 3 and BC has length 8 centimetres. So we know that that length is 3. We know that that length is 3. And we know that that means that we've formed a little square here. So this is 3, this is 3, and this must be 5. And that must be 5. Suddenly this problem looks really good, right? Because we can make that x. But we also know that this distance here must be the same as, let me just do this with another colour. So we know that that length and that length are the same because they too are coming from tangents. Now I'm going to take off too much now. There. Let's take off that ugly line. So that means that this length is also x. And we're basically done now, right? Because we have a right angle triangle and we can use Pythagoras. From there we're going to get our x and then we're going to get the perimeter. So we have x plus 3 squared plus 8 squared is equal to x plus 5 squared. X squared plus 6x plus 9 plus 64 is equal to x squared plus 10x plus 25. Get rid of the x squareds. That leaves me with, what have I got? 73 minus 25 here is equal to 4x. So that's 48 is 4x. X is equal to 12. And the side lengths are x plus 3, 8 and x plus 5. So x plus 3 is 15, 8 and 17, which is a pretty common Pythagorean triple. And so my perimeter is the sum of those, which is 15 plus 8 plus 17, which gives me 40 centimetres. So there you go, heaps of other ways to do that. Just before I go, remember that the other rule that is really common about tangents is that the tangent, let me just draw it, hang on, let me get rid of all of this. The tangent is perpendicular to the radius. Okay, so here we know that that angle is 90. I'm trying to think if I used that indirectly in here. I don't think I did. There were other less straightforward ways on this problem where you could have used that property, but you didn't have to. So you could have done a 5 here, and you knew that that was 3 there, so you could have worked that out. But like that's just a long way of getting to where we got to using our rule. Okay, thanks for watching. Some of the harder questions, especially question 5, the complex numbers ones, coming up tomorrow.